Hey guys, it's Mr. Kennedy, and I just wanted to give you a quick video on water and the environment real quickly. When we talk about water, why are we even worrying about studying water? Well, it's because all life occurs in water either inside or outside the cell. So it's vital to how the cell operates, especially when you talk about the plasma membrane and how it has hydrophobic and hydrophilic qualities. Now, the chemistry of water is pretty simple, right? You have an H2O molecular formula. That means you have two hydrogens and one oxygen. The hydrogens are positively charged and the oxygen is negatively charged, and they attract each other. And it is a sticky molecule. That means the oxygen of one will attach to the hydrogen of the other, as you can see down in this diagram in the bottom of the page. Now, it really has five special qualities. The first one is cohesion and adhesion. This is surface tension. This is what allows some animals to walk on top of water. Is because of the surface tension. It's the way the water molecules bind to each other. The adhesion is the capillary action. If you ever see a straw and you see the little meniscus, the little bubble down, the water's grabbing, has a higher affinity for the straw on the edges than it does towards itself. It's a good solvent. It's actually called the universal solvent, and that's because it is a polar molecule. It means it has both a positive and a negative end, and it can grab almost any type of molecule and break it apart. Okay. It has a lower density when it's a solid. This is a very unique property. That's why ice floats whenever you put it into your glass of drink. Because it is less dense than it is when it is a liquid. It has a high specific heat, which is also very important in that it takes a long time for the temperature to change. So that keeps our climate very constant because we have so much water on our planet. When that water heats up, it keeps it pretty mild throughout the year. And then the heat, high heat of vaporization. That means it heats and cools slowly. So 4 and 5 are kind of linked together. Now let me go through each one of these real quickly. Cohesion, that's the surface tension. You can see the water strider, how it sets up on top. It's the way the water molecules are holding onto each other. Adhesion is that capillary action, that little meniscus that you see down here in the bottom left-hand side. It's because in this graduated cylinder, water has a higher affinity for glass than it does for each other. How does water get up trees? It does it by cohesion and adhesion. If you think about it, a tree has xylem and phloem. Xylem carries water from the roots up, and as water is leaving the top of the plant, osmosis is carrying it up the plant, but it's aided by this cohesion and adhesive property because it's going against gravity, right? So that's very important if you were a plant. It is a solvent because it can break down almost anything. If you look at this picture here with sodium chloride and water, realize that the oxygen will bind to the sodium, which is a negative to a positive, and a hydrogen will bind to a chlorine, so it'll actually pull it apart. It also, you can see how water has an affinity to things like proteins, for example. All right, what dissolves in water? Hydrophilic means, hydro means water, philic means loving. So hydrophilic dissolves in water because it loves water. It has an attraction. But now realize water is polar. So either polar or nonpolar things are going to be dissolved by water, and the answer is actually polar. Nonpolar things do not dissolve in water. Nonpolar things would be things like lipids and fats. Hydrophobic, which are nonpolar, they don't dissolve in water, and it's because you can see down here the picture of this fat at the bottom, this glycerol and these 3 fatty acid chains. These fatty acid chains are hydrophobic. They're scared of water, they're fearing water, and nonpolar things do not dissolve in water. So make sure you remember that. All right, now the special case of ice floating is because of when the hydrogen bonds form a crystal and it actually separates them a little bit further apart than normal, and then allows them to float. And pretty important to a fish because by it floating, the ice on top acts as an insulation layer, and it actually keeps the water from below freezing. So if you're a fish, this would be a great quality. And I just mentioned here, also if you were in a seasonal lake, as water cools, it sinks, okay? And it causes it to continuously turn over and the nutrients continue to cycle. which is a good thing. You know, all the nutrients don't get to the bottom, so it creates this current, which is vital to us. You know, we have the Gulf Stream out in the Atlantic Ocean that is fueled by this freezing property. You know, about how water that's cooler sinks and warmer water rises, and it's going to continue to make this belt go along. Now, specific heat, I put down here, water resists changing temperature. It takes a lot of heat to heat it up, and it takes a lot to cool it down. You know, water moderates the temperature on Earth. You know, look at all this area outside, you know, all this ocean. This specific heat really affects the climate. Think about these two stars on the map. The first one up around New York is close to the water. It's going to be a little bit more seasonal than, let's say, the dot there. I don't know where in Canada this one is, but it's going to be a little bit colder environment, okay, even though they're both cold. Now, heat of vaporization, you know, we rely on this in order to cool our body, such as we got Michael Jordan up here sweating. While the water is going from a solid to a gas, it requires a lot of heat. You can see how long this line is up here between D and E. It requires a lot of heat to change water to a gas. So whenever I sweat and my sweat evaporates from my body, it takes a lot of heat from my body as well to do this. So that's the art of cooling. All right. Now, one last thing I want to talk to you about is pH. You know, water does split apart into hydrogen, which is positive, and to OH, which is negative. If hydrogens are equal to OHs, then it's neutral. The concentration is 7. If hydrogens are greater than OH concentration, that means it's acidic. So if you have more hydrogen ions than you do hydroxide ions, it's acidic. If you have less hydrogen ions than hydroxide ions, it's basic. So basically the pH scale is acidic's 1, 7's neutral, and 14 is basic. Okay. All right, and you can see some common acids and bases here, and I've even put a definition that acid increases the hydrogen concentration, base reduces the hydrogen concentration. So the pH, the H actually stands for how much hydrogen is there, the power of hydrogen. So the more hydrogens you have, the more acidic it is. The less hydrogens you have, the more basic it is. All right, anyway, I hope this helped you, and I will talk to you very soon.